All right. So this is chapter 11.6. Today we're going to be looking at arc lengths and areas of sectors. So you see here kind of what we're going to be looking at, a circle, and we're just going to look at basically pieces of the circle, both the length and area of them. So we're going to start out with the definition. Now the definition states that the sector of a circle is a region bound by two radii. Okay. Again, these would be the two radii here. Okay, and an arc. Okay, so there's the radii, and then we have our arc right here. Okay, now we could consider it to be this arc, or it could be the major arc that circles all the way around here. So that's why it's stated here that both shaded regions of the circle to the right are known as sectors. So we can almost consider this to be like the minor sector, since it goes with the minor arc, and this gray piece would be the major sector as it goes with the major arc. Okay, so now we're going to go ahead and find some formulas that are going to allow us to do this, and I have a relatively simple example here for us to get started with. On your note sheet, you're going to notice that it's just number 1. Then we're also going to fill in the formulas that are located kind of above and to the right of that. All right, so we're going to go ahead and find the area of this. Now, as I had said before, the way we should think of sectors is, well, this is just kind of a piece of the big sector, or I'm sorry, of the entire circle. So what we should start with is going ahead and finding for the whole circle, we're going to go ahead and find the area, which we know the area of any circle is just going to be pi times the radius squared. And then we're also going to find the circumference, and that'll allow us to find basically the arc length around the entire circle. And that's just equal to, well, if we know the radius, and since we do have the radius right here, we know that that's just 2 pi r. Okay, so to find for the whole circle, we just plug in our values here. So we get pi times 6 squared. And for the circumference, we would get 2 times pi times 6. And so for the area, we end up getting 36 pi. And for the circumference, we get 12 pi. And those will come into play in a sec here. Okay? And so that's our area and our circumference. Okay? Now, we don't actually want to know the area of the whole thing, but if we think of this as just kind of a piece of it, well, this piece is 60 degrees out of a total of, so go ahead and think of how many degrees there are in an entire circle. Well, there's 360. So we can think of this sector right here, okay, sector AOB, as just being 60 degrees out of 360 degrees. Or in other words, 1/6 if we reduce that down. So basically, everything that we know about the whole circle, well, we're just going to take 1/6 of those pieces. Okay? So if we want to know the area of sector AOC, well, that's just going to be 1/6 of, okay, the area of our entire circle, 36 pi. In other words, okay, we could do some cross-canceling here. We get 6 pi. That is the area of this sector here. Now, if we want to know the arc length, and remember this arc length here would be the measure of AB, arc AB, well, then that's just going to be equal to, again, it's 1/6 of the whole circle, so it's going to be 1/6 of our circumference as well. So we're just going to take 1/6 of our entire circumference, 12 pi. Okay, again, we can do some cross-canceling, or you can just multiply it out, and we get that the circumference of just this piece right here works out to 2 pi. Okay? Or not circumference, I'm sorry, the arc length. Okay? And by the same token, we would be able to figure out the major arc, okay, being that it is 5/6, the remaining pieces of our circle. Okay? Now, we do want to be able to write this in general. So, I'm going to have to do some erasing here too. Okay? So we have these pieces here as well. Okay? Right? So go ahead and mark these down in the boxes that are in the box that says the formula for the area of the sector of a sector, and they should have a little arc mark there. Okay, and then the length of a sector, which again we see. Oh, this one shouldn't have the arc mark. This one should. Okay, and we see here that the length of a sector is actually just the length of the minor arc, or the major, if we wanted the length of the major arc, obviously, as well, if we were looking at the gray sector here instead. Okay, so we're going to look at one more example here. Okay, so in this problem, we're given a slightly different scenario. So we are given a radius of 6 for our circle, and then we're supposed to, or we find that the minor arc is actually a length of 18. Okay, so again, we're going to go ahead and try to figure this out. Again, we're looking for a piece, basically this, let's go ahead and focus on this sector of the circle. So let's go ahead and find the whole thing, and then we can figure out how big or what ratio this piece is in comparison to the rest of the circle. So to find that, we're going to use those same trusty formulas. A is equal to pi r squared, and C is equal to 2 pi r. Okay, and if we plug those in, we're going to get pi times 6 squared, since 6 is our radius. And for the circumference, we'll get 2 times pi times 6. Okay, we wind up with 36 pi for the area. And again, this is of the whole circle. Okay, and then we wind up with a circumference that is equal to 12 pi. Okay, and again, this is actually the same as far as the circumferences and stuff go. Okay, now for this problem, what we're going to wind up doing is now we have to decide, well, what piece of the triangle is this? Or I'm sorry, the circle. Now, they only tell us a piece of the arc length this time. So they tell us that this piece right here is 18. So we have to consider, well, 18 out of a total of what? So basically, another way of looking at it is we're always going to take or basically put the piece over the whole. So the piece is 18. The whole, well, in this case, are we going to use the area or the degrees or anything like that? We're actually not, because this is 18 out of a total of 12 pi. Okay. So if we consider that, now we're going to be looking at 3 over 2 pi. Okay, and that is actually what the piece that we're looking at is. So if we want to know, and in fact we already knew the arc length in this particular case, so what we're going to need to find now is simply the we're going to need to go ahead and just find the area. So in this particular case, we have an area. Well, the area of the whole thing is 36 pi, and then we have this piece right here of 3 over 2 pi. So we're just going to say, well, our piece is 3 over 2 pi, so we'll just go ahead and take 3 over 2 pi of the whole thing, 36 pi. And this is a case where cross-canceling makes it nice and easy. We're just going to cross out our pi's. Okay, the 2 cancels with the 36 up here, and we're left with 18. And we get that the area of our sector here is just 54. Okay. Now, if I did want to go ahead and find the area of the larger sector here, well, I know that the area of the whole thing is 36 pi. Well, all I really want to do now is get rid of the blue section. So if I subtract 54 from this, that is going to be the area, okay, of the red sector that we made there. Okay, and you can plug that into your calculator if you want an approximate answer, but this would be good enough if we're looking for an exact answer. Okay, go ahead and continue on to finish up number 3. I will have a video up for numbers 4 and 5 if you do need help on those as well.